values from a data set. So when we collect data with sensors in lab environments or in production environments, often we count that signal starting at some time zero value. So what the author of this talk and presentation needed to do is subtract the value, these biased sensor values, from every value for each batch in his data set. So I've got 95 batches worth of data, and I need to, for each unique batch, I need to subtract, for instance, 0.678 from all other values of the ethanol signal for that batch. So that is just a classic place where a little bit of matrix math and a little bit of clever coding can save tons of time in managing a data set like this. So if you check this out, hey, just with a little bit of code here, I've subtracted out these time zero values. And now every batch is starting at time zero and has zero values for each sensor. And the bias has been subtracted from all the other recordings for that batch. So that's really cool. So I've taken what would normally be like if I were just to have the interface, the jump interface to work with, I might create formula columns for new columns for sensor values, and I may have some row functions and subtractions that are happening in that. Now, maybe that's okay if we only have a couple of columns worth of data, but if we have many columns of data and we have to do this over and over again, well, it's much faster to distill this down into 2 lines of code and let some matrix math do the work for you. So hopefully that's enough for everybody to say, okay, cool. We can do some cool things with matrices. So with that, let's take a step back and just talk about matrices in general and how matrices work in JMP. I'll circle back to this code and kind of describe what's going on here. But in order to do that and do it justice, we do need to take a closer look at matrices in JMP. So let's do that. For the presentation, I'm making a couple of assumptions. One assumption is that everybody's at least familiar with a script window in JMP. The other thing that I'm assuming is that you all know how to turn on the embedded log. So I'm going to be sending messages to the embedded log to help us interact with this code as I'm talking through these different examples. I'm using the write function. Now, I'm using the write function for demonstration purposes today, but if you are writing code routinely, it's very nice to put these write functions in different places in your code to help debug. So hopefully that's another thing that you can learn from this that could be beneficial if you're not using it already. All right, let's step through this example and just talk about matrices in general. So the first thing that we want to do is open up a data table. We're going to do that using JSL, so we can assign that a name that we can, let's get to the, the script window that we want. And it's something that we can send messages to and work with. Okay, so now we have this matrix table. I'm going to dock this off to the side so we can all see it. The matrix table has 4 columns of numeric data, and it has a column of character data. So again, as we're beginning to think about our data in matrix form, we have to think about both numeric values as well as character values, because we all know that we get a mix of these in the data that we interact with every day. Okay, the first thing that we want to do is to move the values from the data table into a matrix form. The function is getAsMatrix. And getAsMatrix can get both values for character columns as well as numeric. So if we just take a look at what this looks like, again, I'm using the write function. I won't say this again, but the write function will print readable messages to the log, which I will clear. And these are line escape sequences. So it's just going to help make things a little bit more readable in the log. I'll use those a couple more times as I'm going through the presentation. So I'm going to run these sections of code here. Let's see, do I have my DT in here? Let's see, I think that, yeah, there we go. Now let's get the write in. Okay. All right. So my matrix is now the numeric values of the first four columns of the data. Notice that it left out the last one. It left out the last one because in matrix, true to matrix math, those have to be numeric values. So it's just going to ignore not columns with character values in them. So I don't have to do anything special to that get as matrix if I just know that I want to get the numeric values. I can pass arguments into get as matrix like column numbers, column number indices, and column names. I'm not going to show that immediately, but I will when we get to the bigger piece of code. This other argument here allows me to pass that column of character data. So I'm going to be very specific. I'm going to call the data table and the column name and the column's namespace and get that as a matrix. So by doing that, I get a list. Lists are bracketed by curly braces in JSL, and they can contain both numeric and character value. In this case, it's all character values, so they would be denoted by double quotes. Numeric matrices are denoted with or bracketed with square braces. So that's the difference in JSL for those. Okay, let's step through these matrices and see what we can learn from them. One thing that we often want to do when we're writing code and using matrices is that we may want to learn what our matrix dimensions are. So hopefully everybody's noticing the change in the log down below in the embedded log. And it's saying that I have 6 rows of data and 5 columns in my numeric matrix. Okay, so let's see what that looks like with a list. So notice I'm using n rows and n columns. There's another JSL function called dim, and that just returns both of these R and C values as a matrix. For lists, it's a little bit different. You're asking for how many items that there are in a list. So notice calls rows, now we're asking for items in a list. And we have 6 items in a list, and that's consistent with 6 rows of data in our numeric matrix. Okay, I'm going to make this a little bit bigger here. Okay, next thing that we may want to do when we're working with matrices is begin to index into the matrix and return values or locations of certain logical arguments. So let's do that. I will say that JSL is a little bit different than other computing languages when we want to index into all rows or all columns of a matrix. So JMP uses 0. Python and MATLAB, for instance, will use a colon. So this first statement here is going to return all rows of column 1. So in the matrix index format, you do rows, comma, columns. So let's see what that looks like in the log. That is going to return 133021. If we look at our data table, 133021. So that's what that statement returns. Okay, how about row 4, all columns? See what that looks like. So notice when I did the first one, my rows are separated by columns. So when I asked for all rows for column 1, I get a matrix that's separated by commas. If I ask for the values of a single row of all columns, notice I have no commas separating it. So that's just how we see the matrix in the log, or even if we've taken a math class, that's typically how we would write that out as well. So value 0, 0, 8, 79, negative 7. So if we take a look at that in the data table, 0, 0, 8, 79, negative 7. All right, so we're beginning to envision how we can harness the power of the matrix as we're going through some of these examples. Now, let's get specific here. Let's get specific and call for row 5, column 3, and see what that looks like. Okay, that's going to return a value of 0. So row 5, column 4. Oh, column 3. Let's do that again. That value is 0. Okay, so that's simple indexing. Very powerful, especially if you're looking for something specific in your data. Okay, let's do the same thing in the list for fun. I think you get the idea. It's just in the list. We're indexing into something that's a comma separated list. If we ask for what item 2 is in the list, that is A. All right, let's do something a little more intermediate, but very powerful. One of the things we may want to do with a matrix is to identify the location of values in our matrix that meet some condition. What's really powerful about that is hopefully you're imagining, okay, well, Jason started out with this example where he subtracted out the 0 values. Well, I may look for the 0 values in a column of data. And knowing the location of those zeros, I can do some really clever things. So the loc function is what we're going to use here. And I will say that I think the vast majority of what I'm doing with matrices, you can do in Python and MATLAB and other computing languages too. So this is powerful regardless of the form that or the language that you're programming in. So the loc function returns the index of values that meet some condition. So let's see what our indices are for if we just say, hey, where are my 0 values in my numeric matrix? Well, my 0 values are at item 10, 16, 17, and 23. So how does that work? We are going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my first 0. 11, 12, 13, 14, 15, 16 is my next, 17, and you get the idea from here. So I can use that index in some pretty clever ways. Let's play around with the loc function a little bit more before we start getting clever, though. What if I just pass the name, my variable representing my matrix into the loc function? What does that do? So this isn't saying just with the syntax. Let me back up just a second. So this is my matrix. Essentially, you get that idea. And then I'm looking for the 0 values. This next one is just going to return non-0 values. So by not putting anything in there, let's see what happens. So we get a much bigger matrix of indices. And you'll notice that, hey, that 9 to 11 skip, well, that's because 10 is a 0 value. And that 15 to 18 skip is because we had zeros at 16 and 17. So I think you get the idea. Those are simple ways of thinking about indexing into the matrix. What can we do with it, though? Well, one thing that we can do is we can replace all values that meet some logical condition with another value. Well, that's kind of cool. So with this chunk of code, I'm going to assign my matrix values to something new that I can edit. And then I'm going to pass in this index. So here's where I'm starting to index into a matrix with a new matrix. So I am going to index into that new matrix with the locations of numeric data that are less than 0, and I'm going to replace those values with 0. So now let's see what that looks like in the log. I have a lot more zeros here, and those coincide with everywhere I have negatives as well as the original 0 values. So again, that's just super, super neat. Hopefully everybody's trying to imagine what some work like this would involve, if I'm just working with the data table and in the interface, I may have to go and create a column formula that has some logical functions in it. I may have to do that across many column formulas. So having these simple statements allows you to really get efficient and compact with your calculations and your code. All right, some crazy kung fu. So let's expand on this idea of indexing into a matrix with another matrix and do some cool stuff. So it turns out that we can index into a matrix with some other matrix. In fact, I can take that list. So you remember my list? If I show that in the log, that's my column of character data. I can pass an index of the locations of rows that contain B's. So those are these rows 3 and 4 in the data table. So remember, with the way I index into my matrix is the first is my rows and this comma, and then the second are my columns. A 0 represents all columns in this case. The rows is that matrix. So we are indexing into a matrix with another matrix. In fact, if I just hit return on this statement, I have to get back into the script window. So that's saying that rows 3 and 4 contain the values that I'm looking for. So let's see what that looks like. Let's see what the subset of that matrix looks like. Okay, so we have 2 rows, right? So 1, 2, 3, 4, 5 columns, comma, next row, 5 more columns. And that is coincident with the values that we see in the data table. Again, if we wanted to get specific, we could put in the index values of 3 and 4 for rows 3 and 4. So when you're indexing into a matrix, the matrix that you're indexing can be multidimensional. So that's kind of cool too. So back to the matrix. That's kind of wild. We have here we can include our dream world in here if we wanted to. All right. Let's do a couple of fun things, and this is going to reveal the trick that I used in that original example of subtracting out the rows of 0 values. I'm going to use a little bit of matrix math to solve that problem. That's another cool thing about working with matrices in JSL is that all of a sudden it opens us up to the world of linear algebra and matrix math. So this is just a couple of kind of cool examples. To solve this problem, the first thing that I need to do is to create a ones matrix or vector. Some people call, when you only have one dimension of a matrix, some folks call it a vector. Let me explain why I need to do that. So there's a formula that I'm going to apply. In this case, let's just assume our scenario here is to center our values in the numeric matrix. One way that we can do that is by subtracting out the mean of the column mean from each item for each column, or each, sorry, getting ahead of myself here, by subtracting the mean, for instance, from 1 and the mean of column 1 from 3, etc. Now, again, if I could do that with some row functions in the data table, but I'm gonna do some math, some matrix math, and solve that problem more simply. The formula that I'm going to use is to compute the mean is going to be A equals B times C divided by R. So B in this case is a matrix of 1 by M, a column matrix of 1s. And C is an n by 1 row matrix of the values for the column. And R just turns out to be the number of rows in the column's value. So let's just write this to the log and kind of talk about what I did. So this is the first stage of subtracting or centering the mean, is coming up with the column mean calculations. So if you can imagine this, I've got a ones matrix and I have a column of values. And what happens when you multiply those together is you're going to do column one, row one of this matrix times by row one, column one of the other matrix. And then the way that it works out in the matrix multiplication is you just end up adding those all up. So the first thing that happens when we multiply that ones matrix by the column values is that you get a column sum. So that's trick number one. The column mean part then is super easy. Then we just divide it by that value of the number of rows. Pretty easy. We did up here, if you remember right, we passed in the row values to a variable. I'm not going to scroll up there all the way and show that, but that's where that R came from. Is a little while ago, we asked for the rows, a number of rows and columns with n rows and n calls functions. So just as a check, there is a column mean function. And technically, if we wanted to do this out in the data table, that's fine. I've actually tested this column sum against really big data sets, and column mean actually does a pretty good job. I can't say that there's a huge benefit for doing a column sum or a column mean in the matrix world as opposed to the data table world. I can't say that I've seen a difference. But you get the idea that I can do that. That's an efficient, effective way of doing it. The next trick, I would argue, is that's not true. If I need to do anything special with the values in that matrix, like for instance, centering my numeric matrix, I would argue, especially when the data table gets big, that it's going to be a lot more efficient to do this in matrix form than it would in data table form. In fact, without doing column formulas, I don't think that there is a really easy way to do that in the data table anyway. So the new formula, what I'm going to do is replace my matrix. So I have a new matrix where I've taken the original matrix, which is an m by n matrix, and I've subtracted from that first an m by 1 column matrix of ones multiplied by a 1 by n row matrix of the values that we want to be subtracting. So remember that, I think I've got a note in here. I'll share this with everybody. Remember that you can only multiply two matrices if the number of columns in the first matrix equals the number of rows in the second matrix. So that's a thing to remember. We have kind of tilted the problem just a little bit here to do this matrix subtraction. But in a couple lines of code here, in fact, technically we could do this in one line of code. I've just done this to make it a little bit more readable. In a couple lines of code, we can center the matrix. So from here, if I wanted, a new data table, I could create a new data table and pass that in. Hey, just to test to show that this works, I'm going to do just a simple subtraction by indexing into the actual value of the original matrix and subtracting those. So that would be row 1, column 4, subtraction from the mean, negative 25.1667. Again, that was a very simple subtraction, and there's that value. So very simple, but also, you kind of have to surrender to the fact that, hey, if I think about things in matrices, wow, cool. I might be able to do something fun and efficient with my code. All right, we've got just a couple of minutes before I kind of want to open this up to discussion. Let's go back to the original code and let's just talk a little bit about what I did here. And I'm going to start back down with the formula. There's my formula, same as what I showed with subtracting the mean. But in this case, I've got a matrix of 0 values. And I'm doing that for each unique batch. So remember, my fermentation process data are segmented by this batch ID, right? So I need to be able to do that subtraction for each unique batch. So I'm using this unique for each function to do that. I'm using logical indexing with the loc function like I showed in the other example, and distilling it down into that simple matrix math formula. And once I get the data segmented that I am working with, I'm doing that matrix math calculation. So we'll just do a quick step through the code here. Hey, of course I needed to find my namespace, and I always like keeping everything to the here namespace to the extent I possibly can. Open up a data table and get my column names and the column name list, because I'm going to be using that list as a means of segmenting my data, and then dumping the new data to a data table. So it's important for me to have some recognition of what the original data table names were. I have to make sure that I'm getting my batch ID, because I want to segment that. So I'm going to get a matrix of batch IDs. There is a clever trick in JSL. If you have repeating values in a column or a one-dimensional matrix, you can use this associative arrays get keys to find the unique values or of a column of data. It's a clever trick. I don't know of a better way to do it, but it actually works quite well. So that's what's going to help me segment my data. Now, this is kind of trivial because the batches are ordered from 1 to 100, but my batch names may be different than 1, 2, 3, 4, 5, 6, 7. So this is more general. And then finally, I get pass my data into a matrix, my data table values into a matrix. In this case, I'm doing a different kind of indexing. I'm saying, give me columns 2 through 9 and pass that into a matrix. So that's just another way of indexing into matrices. Double colon means from 2 to 9. So from there, hey, I want to find my zero values. So I'm going to use that loc function. I'm going to look at that time column, all rows of my time column. So that's my first column of my numeric matrix. And I'm going to ask for the locations where that time value is equal to 0. So there's my logical indexing. I'm going to create some new matrix that I can adjust and build off of. That's this new matrix. If you, anyway, I won't say anything more about that. Once I have that, hey, there's my unique batches thing. So I'm going to use that to step through this loop. And in the loop, I'm going to assign a temporary rows matrix that it returns the unique batches index. So this is going to segment my matrix for me. I'm going to create a temporary zero matrix. So this is the subtract, where I'm going to subtract things to. Once I'm there, I'll do the matrix math for the segment that I'm working on. And then I do it again. And I loop through this for each until I run out of unique batches. Once I'm there, I want to go from the matrix, this code world, into data table world, jump data table world. So I create a new column. In this case, I just find this simple, this first batch batch column I want to be numeric. And I know all the others can handle just the default. It's numeric, so it's going to dump it into a data table as numeric continuous. I'm happy with that. This one I wanted to change. So I open a new data table and put in one column. And then I go through this number of column. Remember in the beginning, I said, hey, I want to have some traceability back to that the columns list. So that's what this is. It's going to allow me to step through each of the columns in the column name list that I had. And I'm going to use the names within that list to assign to the new columns. That's what this new column statement is doing. And then the set values part is just taking the column from my numeric matrix and pumping it into the data table. So with that, it's a lot of information, very quick. I tried to keep myself to 30 minutes and I'm 3 over. What questions do you have? What thoughts? Either on this code, back to the matrix stuff. Jed, what have we seen in the chat that's interesting?
So, yeah, just while people are thinking of their questions, I think we answered all the chat questions. And maybe here's a softball question that maybe
Sure.
people may have missed. You did something with a matrix and then you had a little tick mark after that.
Oh, I
Um,
did. I missed it. Thank you
yeah.
so
Can you
much.
go over that? Thanks.
You bet. Yeah, where did I do that? I think I did that in this Matrix Fun example. I probably put it in the comments, but yeah, there we go. Yeah, so it's a transpose. So when we're doing the matrix multiplication, remember how I said it matters, how many rows the two matrices have that you're trying to multiply together. Well, if you need to tilt that one's matrix or any matrix, so in this case, I think if we just pass in this without doing the transpose, it's a row matrix, one column, 6 row matrix of ones. Now, if I do the transpose of that, then it turns it into a 6 column, 1 row matrix of ones. So the transpose is really handy when we're doing matrix math. It's used all over. If you took linear algebra, you should be pretty familiar with it. What you may not be familiar with is this little thing that you can barely see if you're old like me. And it belongs to the key that's right below the escape key on your keyboard.
I
Thanks.
learned that the hard way from someone else's code. I thought that it was a typo, and so I deleted it, and then nothing worked.
Or sometimes you think it's a speck on your computer screen, so
Yeah.
you try and wipe it off.
Now there is a transpose function. You type
There is, yeah.
transpose, open close
Yeah.
parentheses, but that's the shortcut for it.
It
Thanks.
is, and I don't like typing, so I like to use the short if I can.
Jason, so
Yeah.
Jeb was answering this question, but I think it's worth bringing up. Holger was asking about being able to find the last item in the matrix, if there was a universal that did it. Of course, if you know the location, you can put that in, of course. And then also there's always the kind of n-1 kind of way of, counting from the back to identify it. But any other ideas on, finding the last thing in a matrix, the last item?
Last item. Well, could we see if I still have this in here? What if we did? What if we did? What if we index in this with n rows? So this is going to return. That's going to return the number of rows. So that'll be the last row, right? And then the n calls my mat will return the number of columns, which would coincide with the last column. Could we do it that way? So if we
Possibly.
look at the data table, looks like I closed my data table. Let's get that thing back open again. 3. Yeah. There may be a more clever way. To someone else in the audience? Oh, in Python, it's -1. Let's try that. So will you just so this would be for Holger. You just pass that into the index. Oops, that's not what I wanted to do. There we go. Yes. Okay. So let's try my mat -1. I'm not sure. There's a lot of things that, yeah, it doesn't do anything. Oh, but do I need to, because I've reopened my data table, have I lost this stuff? Let me just make sure that everything is still kosher here. Yeah, I'll just run the whole thing here. Oh, that was the time zero subtracted one. My bad. I'm getting in. Okay, let's
You're in
try
the wrong spot.
the my mat. Wrong window. Try that. What did that do? My mat of -1, it does not look like it did what we wanted it to. In fact, I'm not sure what it did, but we can see.
Gave you everything, didn't it?
It gave us everything. Yeah, it really didn't do anything. So I guess that syntax doesn't work. But yeah, that is considerably simpler to have something -1. That's super cool. Yeah, let me think about that. That's not one that I've played with. I don't know. Is Dawn, are you on? Or Kamal? Any other scripting wizards that
Um,
have a compact way of doing that?
and I wonder if it's different on the list as well, because I know from the character strings, right? There was some built-in ways to get the last string and count backwards versus take the first string and count forward. First character in the string, I should say. Last character in the string.
Oh,
But
that's
yeah,
great. Now I know what I'm doing instead of watching TV tonight.
sorry.
That's what happens. You give me a brain teaser. Yeah, I appreciate the question, Holger. That's going to be fun to figure out. I guess we can post if we come up with an answer to that in JSL that's slick. We can post that to the group. Yeah, other questions. Yeah, maybe some feedback too. Is this helpful? Do you possibly see an application for using matrices in your code or some of the things you're working on? Quiet group. Yes, very helpful. Hey, thanks, Kabir. Appreciate that. Yeah, before I started using Jump, um, in my career, I worked with a lot of lab type data. So, I'd have a bunch of sensors connected to a bunch of stuff that I'm either breaking or measuring for some property. And I've had to work with, a lot of numeric data and some very large character sets as well. And before joining Jump, I used MATLAB a lot. So I've had, a fair amount of experience, kind of digesting these problems in matrix, thinking about them with matrices. So for me, I kind of feel like it's a natural way of thinking about data already. But I know that that's not the case with everybody. Now, I mean, for me, because I've had background and experience, it's funny. I think with all of us that code, we kind of all kind of fall into this where we're really good at the things that we've had to practice a lot. Now there are things in JSL that still just puzzle me. But matrices with practice, I guess my point is with practice, thinking about the problem in this way will feel natural. But you kind of have to dive into it and just wrestle with it a little bit. And it doesn't take long, especially if you've had a linear algebra class. It doesn't take long to kind of get there. So hopefully, yes, it'll be something that everybody can use.
I was thinking the same data, Jason. So we have that map and probe data, and when we do all these tests, some of the junk data come. It's not junk, but what the measurement couldn't measure properly. Then it'll give, minus e to the -9 values and all
Oh,
that.
right. Yeah.
So it's a lot of data, and we have to just. I was creating columns like you started with. Like you got to create a lot of columns to replace data which is not useful. And this matrix is an excellent example for that.
No,
Thinking about a matrix like, 100 columns or 500 columns with like 1,000 rows and something. But I'm going to use it and see how efficient this is. Thank you.
oh, cool. Yeah, you're most welcome, Kabir. So let's see, there's Michael commented, I'm always looking at more efficient ways to achieve tasks. I'm self-taught use a lot of lists and loops, but have always been a bit intimidated by matrices. This was a nice intro. I'll rewatch a few times. Awesome. Thanks for that feedback. And I also fall into the self-taught thing. I think many of us in the audience do. So yeah, I definitely appreciate you saying that.
Kamal thought we could use N row possibly to get the last item.
Yeah, I think that's what you mean. Like, yeah, how are you? I think the different than.
You can use n items for sure, and that'll give you just the last one.
Oh, okay. How are you thinking about that?
My mat, n items, my mat.
My mat.
And then in your brackets, yeah, n items.
I got you.
Yeah.
I see where you're going. Oh, yeah. That might actually work. No, it didn't. What if we
That
just
worked in my
what if we
script
do
window.
this?
Parentheses by the n
square
items.
brackets.
Oh, yeah. Thanks. See how it is? Self-taught here.
Oh, yeah.
Yeah, there we go. Yeah, okay, so that gave 3. Yep, that works. And let's try Kabir's if we're thinking that, not Kabir, Kamal's. So my mat of and row mat. Yep. Try that one. Also did it. Yep. Cool. Nice.
Multiple ways.
I love it. Still not as slick as the -1 thing. That's pretty cool. I think I'm trying to remember, that might actually be true in MATLAB too. But it's been a while since I've coded in MATLAB, so cool. Other questions, other thoughts? I think there was one other comment here that said that this has increased the likelihood of Patrick, session increases the likelihood of my use of matrices infinitely. Cool. All right. Should we give it maybe a second or two more for any thoughts that are percolating?
And Jason, would it be helpful if people have suggestions either in the chat or speak up about future topics? Because we're already thinking about, future
Definitely.
meetings down the road. Kind of open up the floor if people have suggestions.
I think that works well. You want to do that? Spend the last 10 minutes kind of thinking about topics for next session. What say you all? What sounds interesting and fun?
Hey, Jason, while people are thinking about future topics, can I ask you a question? Are you going to be sharing your project file that you used?
Yes.
I'd like to
Yeah, that
look
was
at your
my
code.
intention. Yeah.
Okay, perfect. Thank you.
Robin, I can just upload that to the user group page, right?
Yeah, that would be great. And I'll do the same thing with the recording. And
Okay.
then we will also ask our Jump Web folks to put it on the Scripters Club web landing page too. Yep.
Okay.
Jason, I have one thought. This is Kishore.
You could sure.
This is, I don't know how do we categorize this, whether as a topic for next session, but this question is about profiler, and this is in the semiconductor industry. So we generate, we measure, and we get the data, we create a profiler chart. but we also do simulations, TCAT simulations for what we have actually run in the fab. And simulations also generates data. Now, in Profiler, is it possible to have that curve, the model, two of them overlapping, one coming from the measurement data, one coming from the simulation? So
ooh, that is a really good one.
Well, could copy paste them statically.
You could do
Give you the
that,
same
but
box,
how do you?
that doesn't move. That doesn't move.
yeah.
It's can I say something?
Oh, please.
Oh, okay. I want to make sure you can hear me. So, I mean, I don't think there is a way to do that out of the box, but maybe what you can do is you can save both simulation results and the model results as a column on your data table and put them on a graph builder and utilize the data filters to see how they overlap. That may be like one quick way to get the answer you're looking for.
Yes, that I keep doing. Yeah, that in Graph Builder, we may have 1, 2, 3 factors possible to see at a time. And so Profiler gives us much more flexibility in terms of when you change this value, you slide the scale on any of the x-axis, and then you see the change in the Profiler model, the slope changes, the shape changes. So essentially, the goal is to compare the model that is getting generated based on simulation data versus the model getting generated from the measurement data.
Isn't the measurement data created by using the formula created from the profiler?
Yes.
Okay. Yeah, I guess it will depend on the data and what exactly you're trying to do. Another option might be that on the profiler, I don't know, you probably have tried this before. There's an option to show the data points. Maybe if you can overlay the data points with the curve, that might give you an idea too.
Oh, in Profiler, show the data points. Is that what you're saying?
Yeah,
right. As on the red triangle, there's an option to do that.
Oh, okay. I'll explore that. Yeah. Thanks.
I do think it would be cool to be able to superimpose one model formula over another model formula in the profiler. That there is on the community, there is, what are we calling it now? The wish list. That would be one worth putting out on the wish list. And that wish list is very closely monitored. I'll find it and post the link in the chat. But yeah, I think that would be definitely a good one to post.
Okay.
Would that be helpful if you were to do, model minus simulation and have that be your shown it but on the profiler?
Model minus simulation.
So instead of having a profiler for the actual data, having a profiler for the simulated data, if you can do some sort of like actual versus minus simulated, and then have the profiler show that.
Oh,
Since
yeah.
we can only have one thing on the y-axis.
Yeah. You can see the difference between the two. Yeah. That's
or ratio, depending on what makes more sense.
Yeah.
So yeah, a couple of good ideas there. Feel free to reach out too. Spend a little bit of time and try and muscle through some other possibilities there. I'm not sure if it's JSL though, or scripting. It might be, but yeah, we could think about that a little bit more too. Got a couple of things in the chat.
Yeah, there's a couple of
we've
things.
got a thread going on expression handling. So specifically, expression and eval expression, even some questions about are they the same thing? So that thread kind of might indicate that kind of expression handling 101 might be a good topic. To be honest, that's one of the ones that I think I struggle with still, and I have to think about all the time. So I'd put a vote on that too. Let's see what else we have.
Yeah, I used the expression just this morning, an eval expression this morning, and there was some trial and error with it. So
Definitely, yeah.
I volunteer as some expert as tribute. It's just not me.
Yeah, and then there are others, name expression, and yeah, one thing that might be kind of fun. One of the things that I've done is I've taken Joseph Morgan's little white paper on expression handling and worked through some of his examples. Those are kind of revealing. And I think maybe one thing that could be done in the presentation is to kind of walk through that, but maybe simplify it too. There's a lot of stuff he has in that document. Maybe there's a way to simplify that and then just kind of work through those. I think when you do it once, you kind of begin to understand how these things work. So that could be fun. I saw Jordan, you unmuted. Is that a volunteer?
I was just going to say maybe we should invite Joseph Morgan to give the presentation.
Yeah, that could be cool.
Let's see if he nibbles on that.
Yeah, his talk was really good too. Yeah,
it was.
That guy's like next level computer scientist too. That'd be kind of fun.
100%.
Yeah. Let's see. Did we miss?
I'm hoping somebody answers your question because I don't know the answer to it.
So name expression. I'm going to read it. Let's see. Where does? Yeah, that's that. Holger, I think we should have a session on this.
Yeah.
Because the whole expression, eval expression, name expression, it all has to do with how, what's inside the parentheses are evaluated, what's returned. Sometimes just the statement, the characters that are inside that parentheses are returned unevaluated. Sometimes they are evaluated. You can nest those and they do kind of funky things. So yeah, I think that would be good to just kind of have a holistic look at that. It would benefit me a ton too. Wants to repair a part too. Okay.
Just so everybody's aware, the Jump Marketplace is now up and running. It's a place to go get Jump user, customer, partner created scripts, add-ins, essentially. And that is something that Dan Valente can come in the next session and give us 5 minutes on. So great way to share your scripts and grab scripts for customization purposes. And much more, and it's going to be a much more managed and curated place than, just a folder that has a bunch of them stuck in there, and some get old and some get broken. It's going to be managed.
Cool. Yeah, I'm also noticing Ashley had a request, create tables and graphs by connecting to the data from a server and modifying columns and scripts and publishing to SharePoint as a potential topic. I think we probably need to know a little bit more about the SharePoint connection. But yeah, it could be a topic. Also, Ashley, is this something that you want to know how to do, or is it something that you'd like to present?
You suggested it.
Yeah.
No, always great, always great. We're always looking for presenters.
Yeah, if there's some, also, I think one thing that would be really fun at some point is if, there are any clever scripting challenges that people have solved, if you're willing to kind of share that and talk through it. One thing, and yeah, so that could be fun. So share an example of a cool thing that you've done. Another thing that the European group is doing is bring a script and let the group triage it. Just like even my code, I look at it 3 months later and think, why did I do that? There's 10 better ways of doing what I did there. So that could be a fun thing too. If anyone feels bold enough to um, expose some of their code.
That's right. So we just come out with an old code, and for every one row of script we can delete, that's like we'll someone pays out $10.
I've got an example that's still on the community that someday I'd like to revamp. It got lucky with some mistyping of variables, and I used eval parse instead of an expression, so I'd like to redo it. So I can volunteer that as tribute if nobody else wants to volunteer their code.
Yeah, maybe one way we could handle that too is we could post the code to the community maybe a month before we meet and let everybody have a hackathon and see what they can come up with to improve it.
Yeah. I see we're at the top of the hour.
We are. Should we make a decision? So we had expression handling. We had connecting to databases and pushing things to SharePoint, which I'm not sure of how we would do that, but that could be a topic. Who says that when you're coding, you present the solution? Sometimes it's very helpful to present the problem and what you've tried, and that can really invoke some cool conversation. So I think even that one, if we don't have a solution, it might be fun to have everybody explore, well, what might work, what could be possible. And then we had triage somebody's code. Jed volunteered to put one of his scripts out there. And then we had present something cool that you've done. I think I said them too fast and I said too many. Maybe type in the chat what your top choice is and we can tally. Yeah. So Holger's talking about the SharePoint connector and Jump 19. I believe that was by virtue of the Python connection. So that could be something that we show.
Yeah, I see people dropping off as well. So maybe we punt on deciding exactly which it is, because we're maybe some of the people that wanted to vote had to leave for the next thing. So
that sounds fair. Yeah.
Sounds good.
Maybe you could post that in the community, the kind of the list, and maybe people can vote via the community, even if they weren't on the call or they had to drop off.
Sure.
I like that. That sounds good.
All right. All right. Well, I think everybody's ready to go and build a matrix data version of turkey. Yes.
Yeah.
They could eat their turkey in the matrix.
Cool. Well, enjoy everybody. Have a great Thanksgiving and we'll catch up with you on the next go around.
Good job, Jason.
All right.
Thank
Great
you,
job. Thank you,
Jason.
Jason.
Thank you.